Okay. All right, so this is lesson 9.1, points, lines, planes, and angles. Our objectives are to understand the origins of Euclidean geometry, identify relationships among points, lines, and planes, and angles, classify and calculate angles. Okay, so I've got some blanks on your PowerPoint notes for you to fill in. Here, a point has no magnitude and no size. So in other words, if you look on your GPS or map and you see a dot, that's not to scale, it's just a location. So point is really just more of a location, something to focus on. A line has no thickness, the width extends indefinitely in two directions. Okay, so a line is going to be different than a line segment. We'll get into that later. A plane is a flat surface that extends indefinitely. So the wall would be considered a plane, the floor is considered a plane, this blackboard or this marker board here is considered a plane. All right. But planes, these are finite planes where planes can actually extend out indefinitely by definition. Okay, points, lines, and planes, a capital letter represents a point. You have your line here that extends out indefinitely in both directions, points. Letter alpha. And the plane, they use like an L that's like an L there. All right, so that's just, now all of these are all on the same plane. All these points are all on the same plane. They're not like okay. A half line, a point can divide a line into two half lines, one on each side of the point. Whereas a ray is a half line including an initial point. So a half line is open, whereas a ray is closed on one end. So a half line is open on one end, extends indefinitely. A ray is closed on one end, extends indefinitely. So that's the difference between a ray and a half line. Okay. And so the symbol for a line in this case is a B with two arrows on each end. Notice this open point A, but you're never going to get to point A. It's like if you're trying to go from here to the door, and I go halfway, right? And I go halfway again, and halfway again. So like a quarter, 8, 32nd, 64, and so on. The fraction keeps getting smaller and smaller and smaller and smaller, but you never do get to the door. Okay, so that's why we have an open circle like that. And so for a half line, you have the symbol is a circle on one end and an arrow on the other. Okay, and then here this next one is a half line going. Now, when you annotate it with the endpoint first. So here the endpoint is on A. The first one, the endpoint is on A, right? And so here this would be half line AB. Whereas the second one, the the endpoint is at B. So the annotation starts at B to A. Okay, so that's like the starting point, is that endpoint. The ray, again, same thing. Now here, ray is closed at point A and continues on. So notice here there's a dot for ray AB, whereas up here at the line, there's two arrows. So that's like comparing and contrasting the two. Okay, and then ray BA, again, the endpoint is on line at point B. And then line segment, the difference between a line segment and a line is the line segment has endpoints, whereas the line segment terminates. It has a beginning and an end, whereas the line continues on indefinitely in both directions. All right? Okay, questions with that? All right, parallel lines are on the same plane and never meet. So I always like to use the expression of a railroad tracks, right? So parallel lines, they're on the same plane, right? So you can put these markers up on the board, and they're on the same plane. Same plane, no matter how you look at it. Whereas in intersecting, lines are still on the same plane, but they meet at a single point. They don't have to be perpendicular, they can be angled. Those are intersecting lines. Whereas skew, you've got one line going this way and one line going this way. They are neither parallel nor on the same plane. Neither parallel nor on the same plane. If this marker was turned like that, now they're on the same plane, they're parallel. Okay, or is this one, these two are parallel and on the same plane. But with skew, they're neither parallel and they're neither and nor on the same plane. Okay, for skew. Okay, parallel lines, parallel planes rather, they never meet. They're like railroad tracks, right? But instead of lines, they're actual planes. Like that wall there, that's one, the left wall, that's one plane, the right wall, that's another plane. They would be considered parallel planes. Or if they were to keep going, they would never meet. Whereas intersecting planes, they intersect. So in other words, wall here is one plane and the side wall is another plane. You can see where they intersect at forms. Okay. All right. Any questions with that? Okay. Angles have two rays with a vertex as an endpoint. Okay. So angles are two rays with an endpoint named the vertex. Okay. Angles are measured by the amount of rotation. Positive angles rotate in a counterclockwise direction. So if you were to look at these two markers, for example, as two rays with a common vertex as an endpoint, as long as they're moving one, you've got an initial side and a terminal side. The angle moving counterclockwise is a positive angle. If they move in a clockwise, if the angle moves in a clockwise direction, the angle is negative. But we don't get into negative angles in this lesson. Okay, and an angle that moves completely in a complete circle that's 360 degrees, that's also considered an angle. 360 degrees is an angle. Okay? All right, so here we are. Angles are classified in name and reference. So between 0 and 90 degrees is considered an acute angle. So you want to fill those in on your sheets. Can we get off the cell phones, please? Appreciate it. Okay, and then so while you're writing that, I'm going to go ahead and get a tendency real quick. All right. So let's see, Lamonte, Tyree, Joey, Jalen. Jalen is here. Ahmad, Darian, Joel. Joel is here. Ali Juan, Jamil, Joel, Kenneth, Shania, Kellyanne, Strader, Jasmine, Terry. Okay. Right. Okay, so so 90 degrees, that would be a right angle. Greater than 90 but less than 180 is an obtuse angle, and 180 degree straight angle. So in other words, if an angle, this meter stick here would be considered a straight angle, 180 degrees. So you would think, well, that's not a big deal, but it is, because when we get into parallel lines and looking at angles and things like that, you can use straight angles to help you find other angles. Okay? So an obtuse angle would be if you were to go beyond 180, right? So if you looked at this angle here to where this marker is, that would be an obtuse angle. Okay? Anything before 180 degrees, or before 90 degrees rather, is considered an acute angle. All right. When two lines intersect, they form right angles, are called perpendicular. So you want to draw in two lines. So this box here, most people think, well, that means 90 degrees. Well, it forms 90 degrees. What it really means is that two lines, these two lines here, are perpendicular. So that box means the lines are perpendicular, and perpendicular lines form 90 degrees. Okay, so it actually means that the two lines are perpendicular, but they do form 90 degrees. Okay, this means in the figure below, the pair angle ABC. I thought I fixed that. Oh, I know what it was. No. There it is. Okay, so on this next page here, this is what you're going to fill in. So you're going to fill in these vertical angles here. So angle ABC and DBE, ABC and DBE, okay, so we're looking at ABC and DBE. Those angles are considered vertical angles. So they're like scissors. Okay, so if you took two markers, right, and you squeeze them together, the two side angles are always going to be the same measure. Or if you widen them out, they're still going to be the same measure. So that's vertical angles. They're like scissors. Angle DBA, and EBC are also vertical angles. So the opposite angles are vertical angles, okay? And they're of equal measure. Vertical angles have equal measures. So you want to write that in there. So anytime there's something to write in, it's something that's important to remember. Okay, so that's why I did it like that. All right, so let's take a look at this problem here. Find the measure of the angles below. So we can see, now in geometry, they're not going to tell you that these are vertical angles and that vertical angles are congruent. But you have to know this postulate here, okay? that vertical angles are of equal measure, or also known as congruent. So we go ahead, and I'm going to put this up here, and we have 3x plus 10 and 5x minus 10. Okay, and so here's our board, and we want to solve. We want to find what the measure of those angles are. So since we know that vertical angles are congruent, we set these equal. 3x plus 10 equals to 5x minus 10. Okay? So in geometry, when you see a problem, you have to remember the postulate that vertical angles are congruent. And that way you know what to do with these two equations. In this case, you have to set them equal to each other. Okay, so from here, what are we going to do? Can we get off the cell phones? Thank you. Cell phone. All right. Yeah, you want to get the x's. It's helpful to get the x's together first, because then you don't have to mess with negative x. So we want to go ahead and combine like terms. We're going to, in this case, I would recommend to combine the x's and keep the x positive. So I would apply negative 3x to both sides. And so that gives you 10 equals to 5x minus 3x is what? 2x minus 10. Okay. So now we're trying to isolate that x, right? So that means, what do we got to do with this 10 here? Yeah, plus. We apply plus 10. Plus 10. So here we're subtracting, right? And they cancel out. But what are we doing on the left side? Are we adding or subtracting? The 10s. Well, that's positive, and that's positive. So that means that would make it 10 plus 10 is what? 20. So you have to be careful, because on one side we subtracted, on the other side we added. So that's why I like to put the actual numbers and what we're doing, either applying a plus or a minus on them. Okay, so now we want to isolate this x, so we've got to do something with that too. We want to make it become a 1. So since this is 2 times x, right, what are we going to do with that 2? Divide it. Good. Divide 2. Divide 2. And we get the 2's cancel, they go to 1, right? And we get x equals to 2 divided by 20 is 10. Okay, but that's not our answer. We want to figure out what these angles are. So we take that 10 and we substitute it back in. So this would be 3 times 10 is 30. Plus 10 is 40. So if this angle is 40, then the other angle should be 42, because opposite angles are congruent, or vertical angles are congruent. Opposite or vertical, same thing. So 5 times 10 is 50, minus 10 is 40. So these angles are the same. So we can say that our answer is, and if we wanted to put it in set notation, 40 degrees. Okay, and that's our answer. Questions there? Okay. All right. So, and you can check it by, knowing that both sides, both angles should be the same. If they're not, then something went wrong with the algebra, probably. Okay, so we got more spaces to fill in here. Okay, if the sum of the measure of 2 acute angles is 90 degrees, so you want to put 90 degrees in there. If the sum of 2 angles is 90 degrees, the angles are complementary. So complementary angles are add up to 90 degrees. Okay. So, for example, 50 degrees and 40 degrees add up to 90. They would be complementary angles. The sum of two angles that are 180, so you want to fill in 180 there, are said to be supplementary. So two angles that add to 180 are supplementary. Okay, so 50 and 130, they add up to 180. Okay, questions there. Okay, so we've got two angles here, right? Find the measure of each marked angle below. Now notice we have a straight line. So we said a straight angle is how many degrees? So how many degrees is this? Straight line. What? 180. So we could say that since these two angles add up to 180, these two angles would be what? Supplementary or complementary? Yeah, they're supplementary, right? So since these are supplementary angles, they're going to add up to 180. So you have to know that because you have to know what are we going to do with these equations? How are we going to set up our, make them, add them and make them equal to 180, right? So I'm just going to reconstruct this figure here. So this is 2x plus 45, and this is x minus 15. Okay, so here's our board. So since these two angles add up to 180, right, then we could say 2x plus 45 plus x minus 15, 15, equals to 180. Okay, so you're either going to set the angles equal to each other, set them, add them up to equal 180, add up to equal 90, and that's usually that's all we've got. So you have to know the relationships of the angles. Okay, so from here, once you set it up, this is the hardest part. Once you get this part, the rest of it's just algebra. Okay, so we're going to combine like terms, right? 2x plus 1x plus 45 minus 15 equals to 180. So all I did is I just switched places with the x and the 45. So 2x plus 1x is what? 3x. And then 45 minus 15 is 30, right? Equal to 180. All right, now what? Okay, minus 30, minus 30. So that's going to give us 3x equal what? Yeah, 3x equal to 150. So now what do we do? Okay, divide by 3, divide by 3. Well, if 3 divides into 15, that's 5. 3 divides into 150, that's going to give us what? 50. Now what do we do? Yeah, plug it back in, right, to our angles. So 2, I'll use red this time. 2 times 50 plus 45. 2 plus 50 is 100. So 100 plus 45 is 145. Okay, so here 50, this will be 50 minus 15 is going to be 35, right? So 35 and 45, you can check it by 35 and 45 should add up to 180, right? Well, let's see if it does. 145 and 35, 5 and 5 is 10, that's 8, 180, and it checks. Okay, so our answer here is, this is a degree, this is supposed to be a degree symbol here. Okay, so our answer is 145 degrees and 35 degrees. Okay, those are our answers. Questions with that? All right. Okay, angles formed when parallel lines are crossed by a transversal. So you have two parallel lines, and the line that crosses them is known as the transversal. So we label these angles 1 and 2, 3 and 4, 5 and 6 and 7 and 8. Come on. Go ahead and grab the notes there. Okay, so two angles formed will be discussed. All right, so what we want to fill in here is when parallel lines are crossed by a transversal, alternate interior angles. So we want to know what are the alternate interior angles. Well, think of the interior as like the interior of a car. The interior of a car is what? Inside or outside? It's inside, right? So the interior angles are going to be angles inside or in between the parallel lines. So the interior angles are angles 3, 4, 5, and 6, right? But alternate interior angles are alternate in terms of the transversal. So angle 3 and angle 6 would be considered alternate. And also angles 4 and 5. Okay, so you want to fill those in. All right. Angles 3 and 6 and 4 and 5. They're inside and they're also alternating sides in reference to the transversal. Alternate exterior angles would be the angles that are exterior or outside of the parallel lines, and then alternating sides from the transversal. So 1 and 8 would be alternate exterior, and also 2 and 7. The 2 would be here and 7 would be on the other side. All right. Questions with that? Okay. So angles formed when parallel lines are crossed by interior angles on the same side. So same side interior angles. So they're going to be inside or outside? Inside. And are they going to be? They're going to be on the same side of the transversal, right? So you would say angles 4 and 6 or 3 and 5 are same side interior angles that are same side interior angles. Corresponding angles are on the same side of the parallel line. So in other words, 2 and 6 are above or on top of the parallel lines, right? And they're both to the right of the transversal. So corresponding angles are on the same side of the parallel lines and the same side of the transversal. Okay. So corresponding angles are congruent, are equal measure, or also known as congruent. Whereas same side interior angles add up to 180. So you want to underline that, add up to 180, same side interior. And whereas corresponding angles are equal measure, underline that, because those are important. Okay. All right. So here we have two angles, right? Are these two angles, and we want to find the measure of these angles. Are these two angles, what would they be? Corresponding, same side, interior, alternate interior, right? Good. So alternate interior angles are what in relation to each other? They're equal, very good. So almost all of them are equal. The only ones that are not are what? Yeah, ones that are on the same side, right? Same side, either interior or exterior. So here we have parallel lines cut by transversal, and we've got 3x minus 80 and x plus 70. Okay, so we know that the first thing is to identify alternate interior angles are congruent. So that means we set the angles equal to each other. So that would make this x plus 70 equals to 3x minus 80. Okay, go ahead and solve for this equation and determine what the angles are. All right, go ahead and do that. All right, go ahead and work that out. Now I'm calling somebody to give me the answer. All right, you go ahead. Okay. Now, what do we want to do first? Okay, combine like terms, right? So we could combine the x's, that way they stay positive. So that would be 70 equals to 3x minus 1x is 2x minus 80. And then what do we do? We got to move that 80, right? Yeah, right, plus 80 plus 80. Well, here we're subtracting, right? Negative 80 and positive 80, they go to 0. So that'll be 2x equals to what? 2x. Yeah, 150, right? So we divide by 2. What? Okay, so, well, it's not quite 45. So 2 divided by 150 is 75, right? Okay. So, questions? Okay, so if we took this 75 plus 70, that would give us 145. So this side should be 145, right? So 3 times 75 is going to minus 80. Yeah, so that's also 145, right? Okay, so that's our answer. 145.
So you put it into both equations to make sure you have.
Yeah, you put them in both because they should, because these are alternate interior angles, are congruent. You put them in both to check and make sure, because they both should come out equal. If they don't, then you know something's wrong with the algebra. Okay, so whatever you get, I mean, technically, if you put it in one, you got your answer, but you want to put it in both of them to verify that they both equal and that your answer is correct. Okay, questions there? Okay. All right. Okay, so that is the completion of this lesson 9.1.